Hello class 9. Today we will learn about exercise 11.1 construction. Before we begin the exercise, let us learn how to bisect an angle. To bisect an angle, let us first draw an angle. Let us take any length and draw any angle. So these are the two arms of this particular angle, and let us now bisect it. To bisect the angle, first we will take any arc on the compass and draw an arc like this. So here we are getting 2 points of intersection. Let this be D and this one be E, and let this one be point B. So at angle B we have drawn an arc DE. Taking the same radius on the compass, we will now draw an arc from point E like so, and another arc from point D like so. So if we do that, then we can see that we have a point of intersection. Now simply take the scale and join point B with the new point of intersection. We can draw a dotted line or a straight line. Say this be point F. So if this is angle ABC, then angle ABC is bisected into two equal halves, that is angle EBF and angle FBD. These are two equal angles. Now let us draw the perpendicular bisector of any given line segment. To do so, first of all, we will draw a line segment of any length like this. Now, if A and B are the endpoints of this particular line, then we will take more than half of this particular length, not less than half but more than half of the given straight line. Now taking that, we will draw an arc from one end of the line at the top and at the bottom like so. We'll repeat the same step on the other end of the straight line, that is point A. We'll draw an arc like here and here. So we can see that we have 2 points of intersection, one here and here. Let us name them as P and Q. So these are point P and Q. Now let us take the scale and join these 2 points P and Q. If we do so, then we will get the perpendicular bisector of the line AB. Here, if O is the point of intersection of AB and PQ, then we can say that AO is equal to BO. So these two are bisected, as well as it is forming a 90-degree angle right over here. So PQ is also perpendicular to AB. Now let us solve exercise 11.1, question number 1. Construct an angle of 90 degree at the initial point of the given ring. To do so, let us first draw a straight line like so. Now we'll take an arc length or a radius in our compass and take any point as the center of the arc and simply draw an arc. Okay, so we'll mark it as point O. Taking O as the center, we have drawn this new arc and we will mark this arc as A. Now, let us take the same arc radius and we will choose A as the new center and draw another arc so that it intersects the previous arc. From this point of intersection, let us draw another arc on the previous primary arc. If we keep on doing so, we have actually formed two angles. If we name this point of intersection as B and this one as C, then if we join the center O with B, we will get a 60-degree angle right here. And if we join this with O, point C with O, then the angle created here will be 120. Now we have to construct a 90-degree angle, so we are not going to do so. Taking the same arc. Question number 2. Construct an angle of 45 degree at the initial point of a given ray. To construct a 45 degree angle, first we have to construct a 90 degree angle. Now we have already learned how to construct a 90 degree angle in the previous sum. So angle AOD here is a 90 degree angle. We know that if we divide a 90 degree with 2, that is half of 90 is equals to 45 degree. That means if we take the angle AOD, that is this particular angle, and bisect it into 2 equal half, then the angle created here will be a 45 degree angle. So we have already learned how to bisect an angle. So we will take the same arc while constructing a 90 degree angle and we'll take A as our new center. We have to take so because AOD is angle or 90 degree angle. Therefore, we will take A as one of the centers and draw an arc, and we'll take D as another center or this particular point of intersection and draw the arc. So let us draw the arcs here, and from this point of intersection, not here but here, if we draw another arc like so, then we will get a point of intersection right over here. We will join that point of intersection using a dotted line, and the angle created right here is a 45 degree angle. Question number 3. Construct the angles of the following measurements. Number 1, 30 degree. To construct a 30 degree angle, first we have to draw a straight line like so and mark the center as O. Keeping the center as O and taking an arc length, let us first draw an arc. Now, after drawing the arc, we will mark A as the point of intersection of this arc, and taking the same arc length, we will mark here. That is, taking A as the center, we will draw an arc. When we do so, we will get a point of intersection B. If we take this point and join it with the center then the angle created here, that is angle AOB, is 60-degree angle. Now, if we take a 60-degree angle and divide it by 2, that is bisect the 60-degree angle, then we will get a 30-degree angle. So we will do the same thing right here. We will take the same arc length and take A and B as the new centers and draw arcs. So if we take the centers, so let us draw the arcs taking A and B as the new centers. If we do so, we'll get the point of intersection right over here. Let us mark it as point C. If we join point C with O, then we will get the second arm of the angle 30 degree. So the angle created right here, AOC, this angle is a 30-degree angle. Question number 3.2. Construct the angles of the following measurements, 22.5. Now, just like the 45-degree angle, if we divide the 45-degree angle by 2, then we'll get 22.5 or 22.5 degree angle. That means if this is a 45-degree angle, then if we bisect this angle AOP, if this particular point is P, then if we bisect AOP, which is 45-degree angle, then we will get 22.5 degree. So we will take an arc length and construct 90 degree first, then bisect it to get a 45-degree angle, and then again bisect angle AOB to get 22-degree angle. So if we take point A as the center, we will draw an arc like so. And now we will take point P as the center and draw an arc right here. The point of intersection here, let us mark it as Q. So if we join OQ, then we will get the other arm of 22-degree angle. So the angle created right here, that is AOQ, is 22.5 or 22.5 degree angle. Question number 3.3. Construct the angle 15 degree. To construct a 15-degree angle, first we have to construct a 60-degree angle, then we have to bisect it so that we get a 30-degree angle. Angle AOC is a 30-degree angle. Now, if we bisect a 30-degree angle into two equal halves, then we will get each of the angles to be 15 degree. So let's bisect angle AOC. To do so, we will take angle A as the new center and C as another center. Not particularly C, the intersection point of the curve with the line OC. So we'll take, say, let us name it as point D. So we'll take A as the center and draw an arc like so, and we'll take D as the center and draw an arc right here. So we can see that these two arcs are actually intersecting at this particular point, which is, say, point E. So if we join O with E, then we will get the second arm of the 15-degree angle. So the angle created here is 15 degree. Question number 4.1. Construct the following angles and verify by measuring them by a protractor. Number 1. 75-degree angle. To construct a 75-degree angle, first we have to draw a 90-degree angle and a 60-degree angle. 75-degree angle lies between 60 and 90 degree. We can take the difference between 90 and 60, that would be 30, and if we divide it by 2, we'll get 15. So 60 plus 15 will be 75, and 75 plus 15 will be 90. That means the 60-degree angle and the 90-degree angle, if we bisect these two angles, then we will get 75-degree angle. So to do so, we will first draw a straight line, then we will draw a 60-degree angle and 120 followed by a 90-degree angle. So we will take this part or point B as the 60-degree angles intersection and point C as the intersection for 120 degree. Now we will bisect these two angles, taking B as the center of the arc and C as another center of the arc, and hence we have constructed the intersection for a 90-degree angle. Now if we join them using a dotted line, then we can clearly see that this point of intersection creates AOD as the 90-degree angle, and if we join O with B, we will get the 60-degree angle. So if the question comes to draw a 60-degree angle, angle AOB will be a 60-degree angle and angle AOD is 90 degree. Now the question is to find 75-degree angle. So we will bisect these two angles, 60 degree and 90 degree. So to do so, we will take B as the center and draw an arc, and also point D to draw another arc. So now this point of intersection must be joined with point O, and hence we can say this angle created, that is, if you name it as AOP, is 75-degree angle. Question number 4.2. Construct the following angle 105 degree. To construct this angle, first we will draw a straight line, mark O as one of the points, and draw an arc taking any arc length. Taking the same arc length, we will draw another arc at point A, which is the point of intersection between the arc and the straight line. The arc created here, if we join this with O, will be a 60-degree angle. Then if we further take B as the center of the arc and draw another arc, this arc which has been created, if we mark it as point C, then if we join OC, it will be a 60-degree angle. So we can join them to draw a 120-degree angle. This would be 60-degree angle and this is 120-degree angle. To create a 105-degree angle, this angle actually lies between 90 degree and 120 degree. It is equidistant from 90 degree angle and 120 degree angle. If we see the difference, 90 degree plus 15 degree is 105. 105 plus 15 degree is 120 degree. Hence, if we bisect a 90-degree angle and 120-degree angle, then we can say that we will get 105 degree. So let us first construct a 90-degree angle. So we'll take point B as the center and point C as the center and draw two arcs and join the point of intersection with the center. We must draw everything using pencil. For demonstration, I am only using pen. Now that we have drawn a 90-degree angle which is at point D, so we have AOD as 90 degree and AOC as 120 degree. Let us now bisect these two angles. So on the basic arc, if we take at point D as the center, if we take point D as the center and draw an arc, and point C as the center and draw another arc, then we will get this point of intersection. Now let us join it with the center O. Therefore, if we join them, we will get the arc or the second arc for the angle 105 degrees. So hence we can say if this is point P, then angle AOP is 105 degree. Question number 4.3. Construct the following angle 135. To construct a 135 degree angle, first we have to construct a 90 degree angle because 135 lies in the midpoint between 90 degree and 180 degree. So the difference between 90 and 135 is 45 degree, and the difference between 135 and 180 is 45 degree. So we can say that if we bisect 90 degree angle and 180 degree, then we will get 135 degree. So to do so, we have first constructed a 90 degree angle. This is 60 degrees arc, 120 degrees arc, and when we bisect them, we'll get 90 degree. So angle AOD is 90 degree. Now angle AOE is 120 degree. This full angle is 180 degree because it is a straight line. A straight line has 180 degree. So if we bisect from point D and point E, then we will get 135 degree as the mid angle or bisected angle. So to do so, we'll take the same arc length by which we have constructed everything, and now take D as the center and draw an arc like this, and again take E as the center and draw another arc like this. So the point of intersection will now be joined with the center O, and if we mark it as point P, then we can say that angle AOP is 135 degree. Question number 5. Construct an equilateral triangle given its side and justify the construction. What we can do right here is first consider any length of side. So let us consider a side of 5 centimeter. So this is a straight line of 5 centimeter. We can mark it as A and B. Now we know that the length of the sides of all these sides of an equilateral triangle are equal. So what we can do is, if we use the 3 sides, then we can take the same arc length and mark here, as well as taking A as the other center, mark here. So what we can see is that we are getting a point of intersection, taking A and B as the radius of the arcs. Now if I take, it will be point C, and if I join A with C and B with C, we will get an equilateral triangle where all sides are equal. So let us join angle B with C and also angle A with C. Now to prove the construction that it is a correct one, what we can say is that since all the sides are drawn equal, therefore all the opposite angles should be equal, because we know that for a triangle, if two sides are equal, their opposite angles are equal. So for construction, if we take any triangle like so, and if these two sides are equal, then we can say these two angles, opposite angles, are equal. So let them be x and x. Again, as because these two sides are equal, these two angles will also be equal. So if one is x, another should also be x. So we can see the value of all the three angles is x individually. So x plus x plus x is equals to sum of the three angles of a triangle is 180. So we can say this implies that 3x equals to 180 degree. Hence, this implies x is equal to 180 by 3. Therefore, each of the angles, that is x, is equals to 60 degree each. And we know that for an equilateral triangle, all the angles are equal, that is 60 degree.